So here we will try to solve one example related to simplex method, and we try to maximize that problem. Uh, so you will be able to initially form a simplex tableau, and then we will try to appropriate some procedures, and you will try to figure out pivot operation by using simplex method. Okay, so here you can see that this is an example. This is a standard simplex method. You are given one objective function and all the constants are in less than equal form. I will try to solve same example with more explanation on Zoom as well. So we try to solve this system by using simplex method, and you can see that on the previous slide it was written 8x 8y less than 160. This side is less than this side, so to make them equal I need to add something on the left side, which means that, for example, 4 is less than equals to 5. I need to add here something. Now they are equal. What is that number? I want to know what is that number. So similarly I add something here on the left side to make them equal. Later on we will try to find out what is S1, and similarly we will add S2 to make them equal. And one more thing, we always write objective function in this form. You see initially P was 5x and 10y. We can bring P to the other side, to the right side, that is correct mathematically, like 5x 10y minus p equals to 0. But in case of simplex method it is wrong. You always bring this thing to the left side, so it will take minus x minus 10y plus p equals to 0. So here it is like that. Then we write it in a tableau form, simplex matrix form. This is the first equation, this is the second equation, and this is the objective function p. Here we write all our unknowns. Here we write our all unknowns, and here we write our basic variables. What are the basic variables? Basic variables are those under which we have 1 and rest of the elements are 0. You see in S1 we have this condition, in S2 we have this condition, there is 1 and rest of the elements are 0. Similarly in P we have 1 and rest of the elements are 0. So these three variables are basic variables. We write our basic variables on the left hand side as well. We write our basic variable on the left hand side as well. Rest of the elements, rest of the variables are not basic because they do not satisfy this condition. uh, so here you can see the variable s1, s2 and p on the left are the basic variables. Why they are basic variable? A basic variable always has 1 in its column. Basic variable has 1 its column, otherwise 0. Otherwise 0. We can read off its value directly from the rightmost column. X1 and x2 are 0 because we always assign value 0 to our known basic variable. We always assign value 0 to our non-basic variable. Non-basic variables are x1, we will put it 0, x2 equals to 0, and we can get s1 is 160 and s2 is 180 and p is 0. That is the basic solution. Okay, now we start the simplex method. We try to find out the pivot column. The pivot column, we draw this line and we see the bottom row, the most negative number. The most negative number is minus 10. So this is our pivot column. Now we will see the pivot row. How do we identify the pivot row? We divide the rightmost column with the corresponding entries in the pivot column. Like 180 will be divided by 12, so it is 15. 160 will be divided by 8, so it is 20. So the smallest quotient is 15. 12, 15 is smaller than 15, so this is our pivot row. So this is our pivot row, and now you can see that this was our pivot column and this was our pivot row. So this was our pivot element. Now here you can see that x2 is the entering variable. X2 is entering variable. Why x2 is entering variable? Because pivot column is under x2 and pivot row x2 will enter into s2's position where we have pivot row. So x2 is entering variable and s2 is the exiting variable. Why s2 is exiting variable? Because s2 is in pivot rows position. So x2 will become basic variable and s2 will become non-basic variable. How it will become, we will see in the next slide. You see, x2 was entering variable, it will enter, x2 will enter into the basic variables position, and you will see why it happens. Now with the help of this 12, we will make 0 here and 0 here. First we will divide this 12 by this whole equation by 12. We will divide whole equation by 12, we will get to 1. With the help of this one, we will make 0 here and we will make 0 here. So you can see you will get this form, and this x2 will enter into the pivot rows position. Now you see, this x2 is basic variable, this s1 is basic variable, and it satisfies the condition of basic variable, that basic variable has 1 in its column and otherwise 0. Now we again start the simplex method. Again we see in the bottom row the most negative number. So minus 5 by 3 is the only negative number. So this is our pivot column. To decide the pivot row, we divide 40 with 16 by 3 and we divide 15 with 1 by 3. This is I think 7.5 and this is 45. So 7.5 is smaller than 45. So this is our pivot row. So pivot column, so this x1 will enter into the pivot rows position. Pivot row is this first row, so x1 will move here in the position of s1. This is our pivot element. With the help of this 16 by 3, we will make 0 here and 0 here by applying row operations, which we did in chapter 4. Like here with 16 by 3, we divide whole equation with 16 by 3. Here we will get 1. With the help of this one, we will make 0 here and 0 here. You see, we divide whole equation with 16 by 3, we get 1. With the help of this one, we make 0 here and we make 0, we get this form. Now in the bottom row, you see there is no negative number. There is no negative number in the bottom row, so it means that we are done. We will stop our simplex method here and we will read the solution. We will see which one is basic variable. Basic variable is x1 because in basic variables column we have 1 and rest of the elements are 0. Similarly, x2 is basic variable. Here we have 1 and rest of the elements are 0. So s1 and s2 are our non-basic variable, and we always assign value 0 to our non-basic variable. Remember this, we always assign value 0 to our non-basic variables. So if s1 and s2 will be 0, and from here we can read our solution. If I write this system back into the equation form, it will become x1 plus 0x2 plus 3 by 16 s1 minus 1 by 8 s2 plus 0p equals to 7.5. Non-basic variables. S1 is non-basic variable. We always assign value 0 to our non-basic variable. If you put S1 equals to 0, S2 equals to 0, so you will get x1 equals to 7.5. You can directly read it, x1 7.5. Similarly, if we write back this into the equation form, 0x1 x2 minus 1 by 16 s1 plus 1 by 8 s2 plus 0p equals to 12.5. As I said, we assign value 0 to a non-basic variable, so s1 and s2 will be 0, so you can get directly x2 is 12.5. Likewise, you can see here, and p is this. So you can see x1 is 7.5, x2 is 12.5, and we are getting the maximum profit at this point. So this is called the simplex method. Numbers of variables determine the number of basic variable and number of non-basic variable. This is the very first step. Selecting basic variable. A basic variable can be selected as a basic variable if it corresponds to a column in the tableau that has exactly one non-zero element, usually 1, and the non-zero element in the column is not in the same row as the non-zero element in the column of another basic variable. This procedure always selects p as a basic variable, since p columns never changes during the simplex process. This is very important explanation. Try to read these 3 steps again and again, and if you have any question, you can consult with me. After selecting basic variables, are selected in step 2, the remaining variables are selected as non-basic variables, and non-basic variables are always assigned value 0. Don't forget it. The tableau columns under the non-basic variables usually contain more than one non-zero element. Then locate the most negative indicator in the bottom row, like in the first step which was -10, and the negative number with the largest absolute value. The column containing this element is pivot column, and then we decide pivot row. After this, how do we decide the pivot row? The pivot row is the row corresponding to the smallest quotient obtained. If there is a tie for the smallest quotient, choose either row. So maybe there would be same quotient like 7.5, 7.5, then this is your option. You can choose either second row as pivot row or the first row as the pivot row. If the pivot column above the dashed line has no positive element, there is no solution and we stop. And the pivot is the element in the intersection of the pivot column and the pivot row. Note the pivot element is always positive and never appears in the bottom row, right? So this is the simple procedure. Now multiply the pivot row by the reciprocal of the pivot element to transform the pivot element into 1, and then apply row operations to transform above and below 0. So here there is a simplex methods procedure. The very first step is what we do. Step 1, write the standard maximization problem like your objective function and in the constraints form like ax by less than 1, a1 x2 by less than 3. I am writing it in general form. Step 2, are there any negative indicator in the bottom row? Like when you write it in a simplex tableau form, in the bottom row, is there negative indicator? If there is no negative indicator, then you will stop it. You cannot find the optimal solution. If there is a negative indicator in the bottom row, then select the pivot column. How will you select the pivot column? By selecting the most negative number, the maximum number in the bottom row, or the maximum negative number. Are there any positive element in the pivot column above the dashed line? Then you will see, let's say this is -10, this is -5. You will see, is there any positive element above the dashed line? If no, then the linear programming has no optimal solution. If there is no positive number above the dashed line, if there are some positive numbers, then select the pivot element and perform the pivot operations. How will you select the pivot element? You will divide these numbers with these last numbers. You will divide this number with this last number, you will divide this number with the last number, and the smallest quotient will give us the pivot element, pivot row. That would be the pivot row, and then this would be the pivot element. Select the pivot element and perform the operations, and you can keep repeating it until you finish it. Here you can see one example, like a farmer owns 100 acres farms and plans to plant at most 3 crops. The seed for crop A, B and C costs this. So he wants to maximize his profit. When you will formulate this problem, we say crop 1 A, x2 is crop B, x3 is crop C, and the farmer's objective is to maximize his profit. His profit on first crop is 100, and his profit on the second crop is 300. His profit on the third crop is 200. He wants to maximize his profit. So these are the constraints which are given in the problem. You can go through from it. It is very easy to formulate these constraints, like the total number of crops he has are, total area is 100, and his total budget is 3000. He can spend maximum, and number of labor hours are 160. Now we will write them in a standard maximization problem. All the constraints are, you can see, in the less than equal form, and we have objective function, so it is a standard maximization problem. We will add slacks s1, it will become equals to 100, 40x1, 20x2, 30x3. We will add second slack, it will become 3200. Similarly, x1, 2x2, x3 plus s3 equals to 60. So this is our objective function. We will move this objective function to the left side. As I said, we always write objective function in this form. Plus p equals to 0, and here we will add slacks, then it will become equal. So it would become your standard maximization problem. Here you can see this is your standard maximization problem. Now we will write it into the simplex tableau form. When you will write it in simplex tableau form, s1 is basic variable, s2 is basic variable, s3 is basic variable, p is basic variable, because they have 1 in their column and rest of the elements are 0. So we move this, we write all the basic variables on the left side of the column, and now we decide the pivot column. We draw this line. In the bottom line, the most negative number is minus 300. So this is our pivot column, and now we want to decide the pivot row. You will divide 160 with 2, 3200 with 20, 100 with 1. The smallest quotient is 80. So this is our pivot row, and this is our pivot element. So this is our pivot element because this was pivot row, this is pivot column. So this is our pivotal element. With the help of this 2, we will make zeros above and below. First we convert this 2 into 1. We convert this 2 into 1, and this x2 will move into the s3 position. So with the help of this one, we will make 0 here, we will make 0 here, and we will make 0 here by applying row operations. You will do it by yourself. You see here, now this x2 is basic variable, and we write basic variable into the basic variables position. Again start see in the bottom line, is there any now negative number? Yes, there is minus 50 in the bottom row with only negative number. So this is our pivot column, and when you will divide this 20 with 0.5, 1600 with 20, 18 with 80 with 0.5, you will see the smallest quotient will appear corresponding to 20 divided by 0.5. So this is our pivot row. So this is our pivot row. Now with the help of this x3 will move into the pivotal rows position. Pivotal row comes here, so x3 will come here. So with the help of this 0.1, we will make 0 here, 0 here, 0 here. First we will convert it into 1. So now you can see in the bottom row we cannot see any negative number. We cannot see any negative number in the bottom row, so it means we are done. We write back this system into the equation form. Our non-basic variables, x1 is non-basic variable, s1 is non-basic variable, s2 is basic variable, sorry, s2 is still basic variable, s1 is non-basic variable, s3 is non-basic variable, because we don't have 1 and rest of the elements are 0. X2 is our now basic variable, x2 is basic variable, x3 is basic variable because we have 1 in their column and rest of the elements are 0. Likewise we have s2 is our basic variable. So we assign value 0 to our non-basic variable. X1 is 0, we assign value 0 to our non-basic variable. S2 is s1 is non-basic variable, we assign it value 0. So when you will read the solution, x3 is 40, x2 is 800, and x2 is 60, and our profit is 26,000. So this is how we do this. And if you write it back into the equation form, you will see the same thing by assigning value 0 to our non-basic variables. So here s2 equals to 800. It tells us s2 800 tells us that he doesn't need to spend all 3200. He can still get maximum profit if he invests only 2400. He can save 800. This is extra, this is slack. He can save 800 and he can still manage to get the maximum profit, which is 2400, and he don't need to apply spend all 3200.